So after writing the prediction logic in the last video, I just made one more change to our code, which is to basically import this particular package, that is import getPass. And this package would help me paste my API key into this global variable, which I defined in the last video in a safe manner. We don't need to include this package in the requirements.txt file because in a production grade system, things would be done differently on the AWS cloud platform. So basically, what happens is, let's say if you're on a call with your client or maybe in your team, and you don't want to display the API key which you're passing, this particular package would help you do that. So also coming to the text portion, like basically testing the entire application, like I have taken these like text components, or basically these paragraphs from different news articles, and like basically it's pretty long. You can just copy paste anything you find on the internet and test your application respectively. In the production version of the applications, we do not actually do this, and the reason for that is, let's say we take a hypothetical scenario. Let's say if I'm your customer and I call your customer center service, a recording of my conversation with your agent is then transcribed by a speech recognition model, and that respective summary or the transcription, let's say it gets saved on an S3 bucket. That S3 bucket is then linked to an API, let's say an event handler, Lambda event handler, and that Lambda event handler, when it sees that a new file has been written to S3 bucket, invokes our LLM using this prediction logic. And then the LLM would basically naturally require an API key, and by using this logic, we have to pass in our API key every time we invoke the LLM, which is not very, the right way to do things. Not feasible as well, because given the sheer volume of requests you would be handling, uh, things should be automated. If you're not familiar with AWS Lambda handler, don't worry about it. There would be the next course actually teaches you how you can deploy your application on AWS Lambda, and then add load balancers using API Gateway. But more on that later. So without further ado, since we've just copied paste this text from the internet, Coco Gauff, the world number 10 women singles player. This was basically based out of a sports article which I copied. It's pretty long, as you can see. Let me just scroll this, etc. etc. The second article is even longer. I've just copy pasted entire news articles, and I try to test my application. So let me just quickly go ahead and do that. So since we are in this folder, we have app.py file. We do Python 3 app.py. It runs the code, and then it asks me that is please enter the OpenAI's API key in the terminal. And then I just copy paste my API key. I go ahead, I paste it here, and I press enter. So then my text is passed into the model. It displays that please write a concise summary of the following. That is the prompt which is being part of the load summarize chain. And since we have already set verbose equal to true, it displays what the particular chain is doing internally. So after this, the concise summary is basically Coco Gauff, age 19, has won their first Grand Slam title at the US Open after exactly etc etc all the way to this point. And then the next chain, which is for this respective text, starts working, which is basically it's a pretty long piece of text. We won't be able to read completely, but it's basically based out of politics. Based on today's date, I was able to copy it from New York Times, and as you can see, like it was able to generate a quick summary of what the article is talking about. At this point, I would like to talk about summarization as a task in NLP. So basically, once you pass in a piece of text to a summarization model, let's say long T5 or Flan or Gupshup or any of those models which are available, Google Pegasus, that is also one of the models. These models actually generate summaries of the text which we have passed based on the kind of task we define. You can find like similar models on Hugging Face. Summarization is done in two ways. It is either extractive summarization or abstractive summarization. In extractive summarization, we basically fetch the same set of words from the original text and combine them together to generate a summary. That summary, since it has the same set of words, can be compared against a ground truth. So, for example, if this was the actual text which is being passed into the model once you're building the application, and as part of your data set, you will also have a human generated summary. Now, um, now whatever summary which your model has created, that could be compared against the human generated summary that is with the ground truth, and then the two could be compared using either ROG score, there are variants of ROG score, and either using blue score. So so basically that would give us the quality of the summary which we have created using extractive summary format. This summary which you see on the screen is abstractive summary. Basically what that means is the text which you have just passed into the model, the model summarizes it using words which are similar to the actual text but are not exactly the same. So the difference between extractive and abstractive, there is also one more difference, that abstractive summary is far more readable, it is more consistent. However, the only challenge is, since we don't use the actual set of words in the original text, comparing the abstractive summary with the ground truth, that is a human generated format of the actual text, may not be feasible, because it is feasible, but the words may not be like one to one compared to each other. So the blue and the rogue scores are directly not applicable here. So a solution for that problem is, based on my experience working on these problems, is like using two models like keybird and like a named entity recognition. Keybird could be used to extract keywords from your generated text and from the ground truth. But basically, that would mean is we extract words which are really important in the ground truth and the generated text. And for those set of words, so let's say we have set number one for our ground truth, like some set of words which have been extracted from the ground truth. Set number two contains all those keywords which are extracted from the predicted text. Then for each of those words in those respective sets, we will be understanding the kind of entity types they belong to using named entity recognition. And then through some logic, we will have to build a scoring function which compares each entity type with the other one in the, like, from set one to set two, and then come across a score. Let's say above 85 or 87%. And let's say if we define a threshold of 80%, that basically means that a model is, this respective model is performing better. And that is how we define a benchmark. But for the purpose of this course, we will not be doing research on this specific topic, because we as machine learning engineers are only responsible for deploying the particular application. This scoring, building of a metric, would be done either by a data scientist or by a research scientist or maybe an applied scientist. So just wanted to touch base on this topic because most people struggle with evaluating the quality of abstractive summaries. So since I've worked in this field before, I just wanted to talk more about that. So in the next course, I will talk about adding more safety to our application, safety and security to our application, and I'll show you how exactly can you use AWS to fetch this particular API key rather than using getPass, and we'll slowly and steadily try to convert this code into an actual production grade code. So see you in the next lecture.